Oh, this is characteristic number 2 and characteristic number 3. Characteristic number 2 we've seen already. How to find horizontal asymptotes. There will be a horizontal asymptote either when the degree is bigger on the bottom or the degrees are the same. So if we want to make a little note off to the side, just make sure I'm not writing on anything here. No. You will get horizontal when the degrees are the same, or when the degree is larger in the denominator, in which case your horizontal asymptote will always be y equals 0. So if that's when we get a horizontal asymptote, what situation do you think you would need to have an oblique asymptote? What situation have I not described in the first two? Yeah, so the degree in the numerator is larger. We won't have any where you have both of those, no. Because they both describe, a horizontal asymptote describes what happens at its end behavior as x goes on forever. An oblique asymptote also explains what happens as x gets really big or really small. So they both do different things. One of them approaches a horizontal line, the other one approaches a diagonal line, so you won't have both at the same time. So this one, the first example, we have the highest degree is x to the 1. We have an x to the 1 on the bottom, and that means that we have the biggest degree in our denominator. So that results in a horizontal asymptote at y equals 0. Just to draw it in, we have a non-permissible value here at x equals -4. That would be a vertical asymptote. If we look at this next example, we have the degrees the same in our numerator and denominator. And the technique that the textbook does, I think, is more confusing than the technique that I've shown you so far. If you just look at those highest degrees, where's our horizontal asymptote going to be? At y equals 2. Right? The highest power on the top is an x. You have 2x over x. That simplifies to 2. That is all you need to know and be able to do. They decided to do something with synthetic division to try to figure it out. We're not going to worry about that. Do they have a picture? There it is. So this one, it has your horizontal asymptote at y equals 2. We have a non-permissible value, so we have a vertical asymptote at x equals 1. And here is the example of oblique asymptotes. So first of all, we can recognize that the degree is larger in our numerator than it is in our denominator. The fact that that happens tells us this one's going to have an oblique asymptote. How do we find the equation of our oblique asymptote? To find the equation of an oblique asymptote, we have to use synthetic division. You could use long division as well. You actually divide them. How do we divide x squared by x plus 1? Well, I would have 1x squared, 0 x's, and 0 constants. I'm dividing by x plus 1, so you remember we put the opposite sign on the outside of synthetic division. You bring the first number down, then you multiply. Negative 1 times 1 is negative 1, and you add. Negative 1 times negative 1 is 1, and you add. What's the answer? The answer is x minus 1 remainder 1, right? That's what the synthetic division answer is. You ignore the remainder. Your oblique asymptote is just going to be the equation that you get with ignoring the remainder. So yeah, this is like y equals mx plus b. So it has a slope of 1, a y-intercept of negative 1. And that's how you would graph. You'd graph it with a dotted line. Okay, so there is a summary, and we're ready for example 2. So again, I'm going to steal the steps here. Oh, this is not going to work. Let's go view, entire page. We're going to keep them off to the side here. So, again, this says use the equation of each function to predict whether its graph has horizontal or oblique asymptotes. In our graphing, that's normally step 2. So we'll follow our steps. We'll still do our vertical asymptotes or holes. But then we'll continue to determine the rest, and then we will actually graph these completely, just to practice that all the way through. Because that's the goal in the end. So if we start practicing it with all of these questions already, you're going to be really set. Because 2.4, the last section in this unit, is just the same thing over again. Just putting what we're doing all together. So we're done this unit. We haven't done all the examples yet and seen all the different cases, but we're basically done this unit and just have more questions to practice. So, question number 1, okay? How do we find vertical asymptotes or holes? You might want to add, well, it says in here, simplify. How do we simplify something? We factor it to see if anything goes away. So I'm going to factor this equation to start with. The top factors nicely to be x plus 7, x minus 1 over x plus 2. So when we're thinking about step 1, will we have a hole or a vertical asymptote? Because we have a non-permissible value. The non-permissible value, x can't equal negative 2. The question is, at negative 2, is it a hole or is it a vertical asymptote? Since x plus 2 doesn't cancel out, oops, we have a vertical asymptote at x equals negative 2. Done step 1. All right? After step 1, it says simplify, which we factored. We have to graph the simplified equation. Nothing canceled out, so we're still going to graph the entire equation like we started with. Step 2, horizontal or oblique asymptotes. What's the biggest degree in this one? It's an x squared. So we have the biggest degree in our numerator. What does that mean? Oblique asymptote or horizontal asymptote? Or, yeah, it's going to be an oblique asymptote. How do we find our oblique asymptote? We use synthetic division. So we set it up. We have 1, 6, -7 divided by x plus 2, so there'd be a -2 out here. Bring the 1 down, -2, add, -8, -15. Ignore the remainder. Our oblique asymptote will be at y equals x plus 4. At this point, once you've done both of your asymptotes, I would say we can start graphing. We can put in the stuff we already know. We know that we're going to have a vertical asymptote at x equals -2. And we have an oblique asymptote. So let's draw our asymptotes in. We have one right here, x equals -2. Our oblique asymptote is x plus 4. That means we have a y-intercept of 4, a slope of -1, so you could go a slope of +1, over 1, up 1. You could, if you wanted to, find the x-intercept at -4. Draw your oblique asymptote and label it. Again, it's really nice to have a red pen for all of your asymptotes. It keeps things clear in your graphs. It helps remind you that you have to draw your asymptotes with a dotted line because you've taken out a special pen. Now from here, step 3, let's find our intercepts and let's find any other points that we need. So first of all, the easiest intercept is your y-intercept. Go to your original equation, plug in 0 for x. If I plug in 0 for x, can you see that I'll have -7 in my numerator, 2 in my denominator, -7 over 2. There's my y-intercept. X-intercepts. Remember the special note we wrote last time, that a fraction is only equal to 0 when your numerator is equal to 0. So when I'm solving for my x-intercept and I'm plugging in 0 for y, I'm going to take my equation, I'm going to rewrite it here. I'm going to rewrite it with the factored form. So we had x plus 2 on the bottom, and we factored it to be x plus 7 and x minus 1. When is my numerator equal to 0? And this is why it's really nice to factor it. Can you see that it's equal to 0 at -7? Can you also see that it's going to be equal to 0 at 1? So we can label -7, 0 and 1, 0. Now with the points that you have, you can finish the sections that you have points. So here, first of all, it should make sense that these points are going to be joined. We have some asymptotes. It makes sense that this one's going to go down towards this asymptote. And over here, it's going to start going up, but there's an asymptote here, so it's going to approach that asymptote. And we have a point in this section, even though it's only one point. We have asymptotes. So here, we have to decide, as I go to the right of this point, could I go down or could I go up? Well, if I went down, I'd go through my asymptote, so it must go up. And here, oh, it should be, that was a little, there we go, that's a probably better curve. Take out my fancy little eraser. Love that little eraser. And that is the graph in that section. So we end up not needing any more points. Our intercepts were enough points because we got a point in each section. Remember, your vertical asymptote, the one at x equals -2, splits your graph into two sections. Oblique asymptotes, they act like horizontal asymptotes. They don't split your graph up into different sections. But I had points to the right of x equals -2, and I had 1 point to the left of x equals -2, and it was enough to graph it completely. Part B. Ooh. Come on, there it is. Once again, I'll start this on a new page, but I will paste all of our steps that we've written down so far. Again, this question was asking about horizontal or oblique, but we would follow all of our steps through each and every time. So first of all, I would simplify by factoring. And it's exact same equation, so we've already factored this. Wow, and we make a mistake. X plus 7, x minus 1. So nothing cancels out. Step 1, our non-permissible values, x can't equal -7 and x can't equal 1. Will we have holes or vertical asymptotes? Nothing cancels out, so x equals 7 and x equals -7 and x equals 1 are going to be vertical asymptotes. Part 2. Do we have horizontal asymptote or an oblique asymptote? We're going to have a horizontal asymptote. The degree is larger in our denominator. And anytime the degree is larger in your denominator, your asymptote will be at y equals 0. So at this point, off to the side, I would start my graph. And label all of my, label all of my asymptotes. Step 3. Find X-intercepts, Y-intercepts, and any other points you may need. Okay? So obviously, we've talked about it. The Y-intercept is the easiest. If we go to our original equation and plug in 0 for x, we get the point 0, -2/7. X-intercept. You have an x-intercept when y is 0. Remember, a fraction is only equal to 0 when your numerator is equal to 0. Can you ever make your numerator equal to 0? Yeah. What would it be? -2. So this feels weird, and that's okay to feel weird because you draw a point on an asymptote. But it is correct. Remember that horizontal asymptotes are really there only for what happens at extremes, big values of x or big negative values of x. A horizontal asymptote doesn't tell what's happening in the middle of a graph. And that is our only x-intercept. Okay? Now, here I have enough information to draw this down this way. To the left of that, you would have to ask yourself, should it bounce off that x-intercept and go down to the asymptote? Or do you think it's going to go through the x-intercept and go up? Okay? If you're unsure, you can draw some other points. For example, if I plug in -3 for x, okay? Can you see up here, if I plug in -3 for x, my numerator would be -1, and this would be 4, and this would be -4. Yes? And if I simplified that, I would get 1/16. So if I wanted to, I could plot the point 3, 1/16. What that tells me is that it has to go up rather than go down towards that next value. It can't go down because we only have one x-intercept and we've labeled it. After going through 3, 1/16, if I went down again, I would introduce another x-intercept, which we know doesn't exist. Our vertical asymptotes in this case, can you see that have split our graph into 3 different sections? I'm just going to finish this 1/16. It split it into 3 different sections. Have we graphed something in each of the sections? No. We only graphed the middle section. So we need to graph the section bigger than x equals 1. Right? Possible numbers to choose bigger than 1? 2, 73, whatever you like. So if we plugged in 2, I'm going to go back up to this equation. I'm going to erase the green that I did last time. Can you see that your numerator would be 4? This would be 9. This would be 1. So my point when I plug in 2 would be 2, 4/9. And as soon as I have that point there, I can draw it towards the asymptotes. I know it can't go down because then I would introduce another x-intercept, and I found all the x-intercepts that there were. Same thing. We need to choose a value to the left of -7. Probably a good choice would be -8. If I erase the green that I did before, and now I plug in -8. -8 plus 2 would be -6. -8 plus 7 would be -1. -8 minus 1 would be -9. Can you simplify? Can you see that that simplifies to -6/9 or -2/3? So I can plug that point in, -8, -2/3. Which makes my graph look like this. All right, questions for practice on this one are 6 and 7.